Okay, and then I already make a record, and then okay, actually yesterday, yeah, not last week, yeah. Yesterday we already talked about the definition of type 1 error, type 2 error, and then the rule of alpha, beta. Actually, alpha is type 1 error, beta is type 2 error, and the effect of sample size. And then today we want to apply into the computations actually. Okay, so I need maybe 5 minutes or 10 minutes your focus to this slide. So, okay, let's start. Refer to the case 1, I mean in the slide here. Actually, we yesterday we already conclude already compute or make a statement about the hypothesis, null hypothesis, and the alternative hypothesis. And then we already done this. The null hypothesis state that the probability of the vaccine, the effectiveness of vaccine is only 0.25, yeah, or 25%. And for the alternative hypothesis, the probability is greater than 0.25 or greater than 25%. And then the next step is determine decision criterion. Okay. Actually, by doing this, we need to determine critical region and the critical value. Actually, what does it mean, yeah, about the critical region and critical value here? Critical region, you can see from this figure, actually this divided into 2 regions, yeah. This the what to say is abu-abu is brown, not brown, silver, yeah. Let's say silver color and the blue color, yeah, blue color. Silver color is region that do not reject null hypothesis, and the blue one, the blue area is reject null hypothesis. Okay. Okay, please focus. In another way or another, we can say also here accept, yeah, accept null hypothesis, and this reject null hypothesis. In other way also is reject alternative hypothesis, and this is accept alternative hypothesis. Okay, I hope it is clear. Okay, and then after we divide it, yeah, into 2 regions, and then we set a certain value, yeah, the certain value, let's say a critical value. Critical value at this time is 8. Let's say 8 here, and the threshold is here, and the critical region where x greater than 8. This is the critical region. Critical region is the region that, yeah, we reject null hypothesis. Yeah, reject null hypothesis. Okay. And then yesterday, Hanif asked, yeah, me, why should be 8? Why should be 8? Why we choose critical value being 8? Actually, choosing the 8 is trivial. We can choose any number. Actually, we can choose any number, and then we can evaluate the critical value by computing type 1 error and type 2 error. Okay. Okay. So by choosing 8 is trivial, so we can choose any value actually. For example, by choosing here maybe 11, we can choose. It's also it's no problem because we need to evaluate based on type 1 error and type 2 error. Okay, until this point. Okay, yeah. Okay, and then we compute type 1 error and type 2 error. Type 1 error define any possibility or probability error when accepting null hypothesis, but the true is alternative hypothesis. Jadi allow me to explain in bahasa. Jadi tipe error 1 adalah kemungkinan error, berapa sih kemungkinan errornya ketika kita hasil observasi menerima HO, ya, menerima fakta pertama, padahal yang benar adalah fakta kedua atau hipotesis alternatif, seperti itu. Berapa kemungkinannya? Logikanya, kalau dugaan kita benar, dugaan kita itu bagus, maka errornya kecil kan? Errornya kecil gitu. Ya, errornya kecil. Oke? Okay. And then how to compute? Yeah. The type 1 error is alpha, and then we need to know the probability x greater than 8. Why greater than 8? Why greater than 8? Why greater than 8? Because we want to accept edge 0, right? We want to accept edge 0 here. This is the area. So any value that greater than 8 will be considered as error. Of course, we are expecting that the area in this region, and then any value that come up greater than 8 will be considered as error. Ya, karena H0 ini kan, H0 itu harusnya masuknya area sini. Oke, kalau observasinya menghasilkan di sini itu betul gitu ya. Tapi kalau observasinya munculnya di area sini, ini dianggap error. Dianggap error. Ya, gitu seperti itu. Oke. And then we compute the probability x greater than 8 when the probability is 1/4, 1/4. Actually, this value coming from hypothesis null, yeah, null hypothesis. And then computing this probability, actually, we can consider as a binomial distributions. Binomial distributions. X greater than 8, so we start with 9 until 20. Yeah, because the sample size is 20, right? And then this is the X. We can compute the cumulative probability, and then we can compute directly, or we can by manipulating. Yeah, it is a kind of manipulating, so it is equivalent to 1 minus probability this one, and we have result this one, 0.0409. It's quite small, means that kemungkinan error menerima HO ketika H1-nya benar itu sangat kecil, ya, kecil lah gitu ya, hanya 4%. Jadi yang selebihnya itu akan berada pada menerima HO dengan HO yang benar, gitu kira-kira. And then maybe I want to show you how to compute this one. You can use, of course, calculator, ya, binomial calculator. For example, let me show you my screen. Okay, now you can see my screen. You can search in the internet, binomial calculator, binomial probability distribution calculator, and then you can, for example, you can pick up one of them, and then this is the calculator that I use here, StarTech online calculator binomial. Okay, and then you can compute probability success is 1/4, and the number of trial is 20, and then the number of success is 8, right? 8, but should be greater, yeah. So there are many possibility here. Which one we should take? Then we compute. Yeah, and then remember that the I will make an annotations here. Is the probability x greater than 8 with p equal to 4. So it's correct, this one. And for the n is 20 is correct, and then this one x greater than 8. This is the x is here. So you can pick up this result. Yeah. So the probability is 0.0409. Okay, it's clear, yeah. Okay. We back to the PowerPoint. Where is my PowerPoint? Okay, here. Okay, that's all. And then for computing type 2 error, by definition is probability error when accepting H1, but the true is H0 or a null hypothesis. Okay, remember that the alternative hypothesis say that probability greater than 1/4, yeah, greater than 25%. So we can trivially pick up a value greater than 20%. So let's say 50%. So we can put here. So maybe some of you asking me, how about if P equal to maybe 3/4? Is it okay? Yeah, okay aja, yeah, it's okay. And then we can check later, and then we can check the beta, yeah, we can check the beta. In this case of in case of P equal to 50%, so we can express being like this: the probability x less than or equal to 8 when P is 50%. Why this x less than 8? Back to the this one. So when we assume that when we want to accept H1, the value that we can observe should be come out in this region, and any value that come out in this region will be considered as error. So that's why we compute error. So this is error, this probability x less than or equal to 8, less than, yeah, or equal, less than. So in this area, right? And then the probability is 50%. Sorry, with 50%. Okay. Okay, back to the this one. Okay, 50%. So okay, so you can use the calculator, online calculator, yeah, this one, and we change this one being this 5 being 5, and the number of trial is still 20, and the number of success is 8. Yeah, and then calculate. Okay. Remember that in this time is probability. Wait a moment. Okay, the probability x less than 8 with probability 1, 2. Okay, and then we pick up this one. This one. Probability x the 8. Yeah, actually this is the small x. Yeah, is equal to 0.257. Wow. Okay, good. Okay, and then we back to the PowerPoint, and then we have this one. Okay, the probability of being 0.25 and 17. Okay, any questions?
Sir, what is the percentage of error that is considered as a big error?
What is the percentage? Which part? Which part?
I mean,
do you mean?
after we find the probability, we get the value of beta and alpha, right?
Yes.
Like for example, the alpha is 4.0%, while for the beta is around 25%. So what is the value of the beta and alpha, or the value of error that is considered as a big error?
What is the value? What do you mean the big error?
Like kayak kita kayak nilai berapa presentasinya tuh berapa yang kita anggap tuh errornya udah besar gitu.
Oh, okay. You mean the threshold that we should consider, something like that?
Yes, sir.
Okay. Okay. Good questions. Yeah. Actually, we are not talking about this parameter, but usually we consider this alpha and beta, and in many application book, not only for some. Usually, in many application, the standard alpha and beta less than 50%. 50%. And if alpha and beta how to say have this value less than or equal to 50% respectively, so we can say that our system, our test is good. Yeah, usually, yeah. It's mean what does it mean? 5%. It's mean that yeah, there is only 5% error in the system. I mean, in the observation will come out. Yeah, when the error is only 5%, we still we have a 95% belief. Yeah, we have 95% probability that our observation will be true, something like that. Okay, is that answering your question?
Sir. And for the trivial value for the alternative hypothesis, can we choose like 0.3? I mean, like a number that is close to the 0.25 but still bigger than 0.25?
Okay, yeah, it's possible. It's possible. So, for example, even you choose the p value equal to 0 to 7. So it is possible. It is possible, and then we need to check. How about the performance of error here? The error is big, the error is not big, something like that.
So we can basically choose the value of the probability so that we get the least amount of error.
Yeah.
Oh, okay, sir. Thank you.
Okay, so that's why in the next slide, what happened if we change the critical value from 8 to 7? Yeah, in this case, so in this case, from 8, yeah, here the threshold is here, and then change to 7, so the threshold is shift to the left, something like that. And then what happened with the type the alpha and beta? And this is the previous conditions when the critical value 8, and this is when the critical value 7. You can see here what happened to alpha. For the alpha, the error increased. The error increased. But for the beta, the error decreased. Okay. Okay. Please look at this result. And then later we will conclude. And then what if we change the P from 50% into 70% for the alternative hypothesis? So we can compute here for the beta being 0.001. Okay, and you can see because changing this one to this one only happen for B, so this only affect for the B. You can see the beta is decreasing, but for the alpha should be equal. The alpha should be equal, yeah, not changing. Okay, you can see here when we changing the probability of one of the for the alternative hypothesis, also the type of error changing. Okay, is there any question? If you don't believe, you can compute by yourself. Okay. So based on this fact, we can summarize what we have learned. Yeah. For fixed sample size, decreasing in the probability of type 1 error will usually result in increasing in the probability of type 2 error and otherwise. Jadi in bahasa, dengan jumlah sampel size yang sama, error tipe 1 itu akan naik atau turun, itu akan langsung mempengaruhi error tipe 2. Kalau tipe satunya errornya naik, maka tipe error 2-nya akan turun. Begitu juga sebaliknya, jika tipe error 1-nya turun, tipe error 2-nya akan naik. Kira-kira seperti itu. And the ideal test, ya, tes yang bagus, when we have type 1 and type 2 error are both small. Jadi keduanya harus kecil. Kalau tesnya itu bagus, ya, kira-kira seperti itu. Solusinya bagaimana? What kind of solution here? The solution is to increase the sample size. Increase the sample size. So when we increase n, yeah, from 20 to 100, and then we can set the critical value, for example, 36. For example, given the data that 36 people are praised 2 years period, and using same way, and then using same way for computing the type 1 and type 2 error, we have, please look at this table. This is the type error alpha and beta. This is alpha. When the P is equal to 1/4, which is 25%, and at the sample size 20 being 4%, around 4%, and the critical value is 8. And then when we have sample being 100 and critical value being 36, less than 1%. Similarly, for the beta is still, the probability is 50%. Yeah. For the sample size is 20, is around 25%. But when we increase into 100 sample size, and then again the error decreasing, less than 1%. So that's the power of sample. So this is very logic and easy to understand. When we have a large sample, so we can easily describe the information in the populations. Jadi ketika kita mempunyai banyak sampel, ya kita akan lebih mudah, lebih yakin mendapatkan informasi yang ada di populasi, atau lebih yakin kita menilai informasi terhadap populasi tersebut, something like that. Okay, any questions?
Hello, sir.
Yeah.
I want to ask, so if we increase the sample size, we would get like a more accurate result? Is it kind of like that?
Yes, of course. Actually, your question already answered in the last, maybe in the last topic. Yeah. Yes. Also, that's how to say, that theorem also can be applied to this case, something like that, RD.
Oh, okay. All right, sir.
Okay. Okay. Any other questions? If no question, I have an exercise here. Exercise. Please, everyone. Maybe we have so many students here. Maybe you have 20 until 30 minutes to conduct this exercise. Please conduct by by group. Yeah, I will break you into 2 groups, and please conduct this exercise. The PowerPoint I will send you to the WhatsApp group. Okay. Okay. Please be ready, and then I will break you into 2 rooms. Alhamdulillah.
Kalau lebih baiknya bareng-bareng, Sir.
Oh ya udah nggak apa-apa. Siapa yang mau duluan? Silakan.
Arel.
Ya Dro, buru Dro.
Gue nge-share apa ya?
Sir, tapi kita gak ditulis di itu, jadi kayak ditulis di kertas gini.
Ya nggak apa-apa, ditulis di Google.
Oh, pakai itu aja ya.
Iya, di share screen aja. Oke.
Jadi, tapi kita betanya belum, Sir.
Oke.
Baru nyari alpha buat N36 sama N64. Bentar. Okay, so for the null hypothesis, we get that the average is equal to 68, while for the for the H1, we get the average not equal to 68. And for the decision region, we decide that for the region accepting a null hypothesis, the range is between 67.5 to 68.5. And outside this range belongs to the H1. And for the type 1 error or the alpha for the n equal to 36. So the formula is we're using Z tabel. Actually, we are using calculator, but I transform it into the Z form first. So the alpha is like this for the n equal to 36. Sorry.
Oh my God.
So for this formula, we choose the average is 68 because we are accepting null hypothesis, but the truth is the alternative hypothesis or the H1 is correct. So that's why we use the average is 68, but for the X or for the X, we choose a value below 67.5 or above 68 0.5 or outside the region of accepting null hypothesis. And then from here, we transform it into the Z, and we got the probability of the alpha is equal to around 40.46% for the n equal to 36, and for the n equal to 64, the formula is the same. We just change this into 64, and we got the alpha is equal to 26.64%. So yeah, basically the value of the error is decreasing as we increase the value of n. So that's all from us, sir. We
Okay.
haven't find the beta.
Okay. Yeah. Yeah. I haven't checked for the calculations. Yeah. But if the calculation is true, and then that's seems to be correct. Yeah. Actually, Hanif, you come from group 1 or group 2?
2, sir.
2. Okay. Group 2. So group, oh yeah, group 2, and the group 2 decided for the decision region located in between. So if I draw thing like this, let's say this is 68, and then the decision region will be located here. This is according to the group 2. So this is the area of null hypothesis, and this is the area of alternate hypothesis. Okay. So in this case, the alpha yeah, the alpha of type 1 error, we can see, let's say this is the probability of hypothesis for null hypothesis. So the error will be located in here, right? Located in here. The dash area here, we can say as alpha or type 1 error. Okay, it is clear, yeah? And the area in case for the sample is 36 will be 40, around 40%, and for in case the n equal to 64 equal to 26%. So actually what happened when the sample size increase is the probability is getting sharper here, yeah, something like this. So the area given this limit getting smaller, something like this. Yes, something like this. Okay. Any questions for my additional or from Hanif explanation and from my additional explanation? Is there any questions? No questions? And you can see here, in case for the n equal to 30, so please look at the yellow, the yellow line here. When you increase the number, how to say, the critical value, let's say the critical value in the left side become decreasing and the right side increasing. So the area inside of this, or another way is area of null hypothesis increasing. It's mean that open to have a probability accepting null hypothesis getting larger, ya. Jadi ketika kita misalkan menggeser critical value-nya, ini berarti kan area H1-nya menjadi lebih besar. Ketika area H1-nya lebih besar, maka error-nya nanti menjadi lebih kecil, gitu kira-kira. Tapi ketika semakin besar di sini, apa yang terjadi? Toleransinya makin besar kan terhadap 68 itu makin luas. Artinya mungkin di sini misalkan dikatakan kalau misalkan batasnya 66 begitu ya, 66. Misalkan kita mendapatkan rata-rata 66,1, ini dianggap masih mendukung hipotesa H0 gitu. Padahal ya ini depend on the accuracy ya, depend on the quality ya, quality of tes kalian gitu kan. Sebagai contoh 661 ini masih dianggap H0 padahal sudah terlalu jauh kan terhadap 68. Nah, ini dari sisi sistemnya tidak terlalu bagus, tesnya tidak terlalu bagus. Jadi sistem yang baik adalah ini tidak jauh dari 68, dan grafiknya sangat tajam. Jadi error yang di luar batasnya ini sangat kecil, begitu. Nah, caranya adalah dengan menambah n-nya ditambah. Kira-kira seperti itu. Oke, the group 1, please compute for type 2 error. Are you there? Group 1?
Yes, sir.
Okay, please, Java.
Okay, wait.
So I stop sharing ya, sir.
Yeah.
Zaki, Zak. Share screen. Zak. I don't use my laptop.
Zaki?
Bentar.
So we compute for this one, yes, sir.
Yeah.
Or okay.
Type 2 error.
So the type 2 error, we use the same formula, which is the type 2 error. It implies that the H1 is true. Yes, sir.
Yeah.
Okay. So we take we assume for the average weight is 70, sir. and then we use for the equation. Wait.
Dava,
Yes, sir.
sorry, Dava. I think it would better if you determine the decision region first.
Okay. Wait. So we haven't actually, but okay, sir.
Okay, yeah, please try.
Is this right, sir?
The decision region.
Is it this one?
Yeah, I mean the step same as the Hanif conduct, same as the Hanif did previously. So you already determine the null hypothesis and alternate hypothesis.
Yeah, for the H0, it says for the H0 is true, and then the H1 is, and then the H1 is for the that not equal to 68 is.
Yeah, please write first. Please write the null hypothesis and the alternate hypothesis.
Is this what you?
Okay, that's correct. And then please determine the decision region.
Decision region.
Decision region.
So if the H0 is equal to 68, then so is it gonna be like this, sir? Oh, berarti is it 67 and
No. Decision region is you create the area, something like this. The area which one that follow for the region for sorry, I use a different color. Okay. For null hypothesis, and then which one the region for the alternate hypothesis.
okay, sir.
Okay.
So we put 68 in the middle, and then the rest is just the okay. Wait. Is it like this? Is it like this, sir?
Yes, but you no need to be equal with previous one. It means that you can choose with, let's say, 66, or this will be 69, also possible. Yeah, but if you choose this value, still okay.
Because
no problem.
we
But
can,
the thing that I want to point out, the meaning of why we put 66 and why we put 69. Why, Dafa?
because it represents the H1, and then the 67 and 69 represent the H1, so the hypothesis one, which is it's not equal to 68. So we gather the nearest number, which is 67 and 69.
Okay, so
yeah,
for the region H0, which one? The region of H0.
This one.
Okay, good. And for H1?
Okay, let me.
Okay.
This one, sir.
Okay, good. Okay, and then when the type error 2 happened?
The type error 2 occurred when when in here, sir, I think, if I'm not mistaken. Is it
okay?
Correct, sir?
Okay, good. So error type 2 is located in this area. Okay.
Yeah. Okay.
Okay. So right now you can write or you can express in the probability.
The equation.
Yeah.
Okay,
Good.
And then it's gonna be. Can I assume it is can I assume it's 70, or should I put 68, sir?
It should be so.
Because it's not.
It depends on. First, you need to clarify the HO. HO is equal to 68. And then if we put in the region, the X is located something like this, maybe this one. This is this one. So the X, and then you already put 67 and 69. Okay, 69, and this is 67. And then which do you prefer? You prefer using this symbol and this symbol, or this symbol and this symbol?
I think I'm gonna use yang nggak pakai equal, sir.
Yang nggak pakai equal. Okay. Yeah. No problem, nggak masalah. Ya, boleh aja pakai kayak gini. Nah, berarti kan probabilitasnya oke. Berarti seperti ini kan? Ini udah benar. Ini maksudnya apa ini?
For the p-type error, the probability of type 2 error.
Ya. Ya kan berarti kayak gini kan? Probability type 2 error seperti ini kan?
Yes, sir.
Okay, and then you can compute.
It's about. Is this correct, sir? The upper one?
Yeah. For the computation, it seems to be correct. Yeah, seems to be correct. Yes, for the computation, and then you can compute using calculator or and so on. Yeah. So
so it's about minus 1.6. 1.6 minus 1.6. 1, 1, 1, 1, 1.16. 1 per. Wait, sir, wait, sir. 69, 1 per 1, 0.6. Lah, kok sama? Minus. I think I might have been mistaken, sir,
Yes.
because it's well, is it gonna the result is minus 1.6 and then z and then 1.6, sir.
Yeah. Seems to be correct. So being like this, right?
Yeah.
Yeah.
So was it okay? 1.6, then
And then you can put the probability under this area.
6 plus 1.6, so it's 3.2 z berarti belum harus dikasih table itu. Si table. Wait, sir, sorry, sir. 1.6 1.6 is 0, 9, 4, 5, 2 minus plus enggak semuanya sama 0,9. So it's about 1.88 blah blah blah, sir. Is that correct, sir?
No, the probability is not exceed 1.
Oh, itu satu yang minus. 0,05. Okay, sir, wait. 9 minus 1. Is it 0.85 blah blah blah, sir?
0.85.
0.85 blah blah blah.
0.8.
If I'm not kebalik.
0,85 ya?
Iya.
Berarti sekitar 85% ya?
Gede banget tapi.
Yeah, seems to be correct ya. Actually, I have not checked correctly by calculator. But yeah, if you want to check using calculator, is okay. Later I will find the calculator.
Okay, sir.
Normal Kaizen. Kaizen kalkulator ya. Mana ini? Kaizen, oke. Interval ya. Interval. Berarti 1,6 ya? 1,6 itunya 1,1 ya?
Yes,
1,6.
1,6 juga tapi minus 1.
Iya. Iya, sekitar 0,8-an lah. Yeah. Let me show you something. But this is still row. Where is mine? Okay, can you close your screen, please? I cannot. Okay. So in this case, actually what you are computing here, wait on. Okay. Yeah, something like this ya. This is 67 ya tadi sampai dengan 69 kan ya. Tengah-tengahnya 68. Itu kita ingin menghitung probabilitasnya yang ada di dalamnya sini kan. Inside the probability, and then you can, by converting to the z, according to your computation, we get -6. This is positive 1.6, so it's around here and around here. So this distribution, because you already normalize into z, the z is mean equal to 0 and the standard deviation equal to 1. So you can use this graph. So you can put here percentile -1.6, and in the second point is 1.6, and then you can calculate here with mean 0 and the standard deviation being 1, actually, because you already normalize being z random variable, and then you get this one. The inner cumulative is equal to 0.89. 0.89. So the beta is 0.89. It means that it's around 89%. It's so big. So big. So it is likely to reject, because the error very large. So it's likely to reject alternate hypothesis. Reject.
Okay,
But
sir.
you can also check using when you increasing from 26 into 64, and then you will get the beta decreasing.
Okay, sir.
Yes.
We found the for the 64 for the problem 1. I think RL tadi berapa? Lupa.
Berapa?
Zak RL daftarkan tadi 0, berapa? Waktu yang nyari itu. Mana? Kok nggak ada?
Kenapa? Maaf.
Yang 64, Zak. Tadi kita nyari yang 64. Wait, sir.
Ya, saya sambil kamu cari ya, saya juga sambil cari. Berarti kan 67 dikurangi 68 bagi 3,6 bagi akar 64. Ya enggak sih? Ini mungkin minusnya jadi lebih besar.
Yes,
Minus berapa ini? 2 ya? 2 atau berapa?
Round 2.
Correct?
Isn't it 2.2, sir?
2.2.
Wait, sir. Let me check again. Yes, this is for calculating the z, right?
Yeah, 2.2.
Yeah, around 2.222.
And in this point also 2.2, right? And
Yes, only the difference is the minus.
so it will be around here, and it will be around here. And you realize that the beta increasing. Well, seems to be. Are you sure increasing? Kayaknya salah. Dua makin besar atau makin kecil? Seharusnya makin kecil dong. Malah makin besar. Oh, ini innernya malah makin besar. Seharusnya kan makin lancip dia. Makin lancip. Grafiknya makin lancip.
Oh. Sir, I think we haven't I haven't subtracted with 1, sir.
1?
1 minus the probability, sir. Tadi.
Oh gitu.
Yeah. Wait. 0. So I think it's around 1.0.89 tadi. 0.11. Kecil banget tuh. 0.1. I think, sir.
Yeah. Yeah, no problem. Seems that the beta is increasing. The beta is increasing in terms of this. In this case, the beta is increasing when the number of sample increase. Because basically, if you see from the case, yeah, this is really depend on the case. You can see here. Let's say for the 67 and 69, and in the middle is 68. And what happened when for example, this is for the n equal to 69, and then when we have sample increase, let's say the new n is 64, and the graph is sharpening, becomes sharper. The sharper, when you still have some critical value, in this case, the area of P the B blue is greater than the B red. You can see here. So I hope it's clear.
I see, sir. Okay.
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 Yeah. Yeah. You can increase your understanding by exercise or by looking at the PowerPoint again. What I have sent to you. And then you can make a question if there is unclarity about my explanation. Anyway, thank you very much for your attentions. I think we already passed the 3 p.m. I hope you don't have any problem. And thank you very much for your attention and see you next week. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, sir.
Thank you very
you,
much,
sir.
sir.
You're welcome. See you.
Thank you, sir.